So the last topic in chapter 14 talks about a very special diagram called a pedigree. If you have never seen a pedigree before, this is a perfect example of a pedigree, what it looks like. This is actually the pedigree of Queen Victoria's family. So take a quick peek and then we'll talk more in just a sec. The main purpose behind the pedigree is to track a certain genetic trait through family lines. When you're looking at the pedigree head-on, typically what you're seeing is just the phenotype, who has the trait and who does not have the trait. After you look through the patterns, you can pretty much go through and figure out the genotypes in order to do some Punnett square scenarios if you wanted to. We would do that in real life scenarios, mainly to track the occurrence of such lethal diseases like Huntington's disease, for example, or even cystic fibrosis, to name a few. Okay, so here are the standard symbols that are used in almost every pedigree that you're going to see. Take a minute to look these all over. Make sure you understand what they mean so that it will come useful for you when it comes time to not only just analyzing and looking at pedigrees, but also making the pedigrees themselves. Now, the reason why I circled this representation of non-identical twins is just so that you would see the difference between non-identical twins versus identical twins. Also, if a person is heterozygous, they may be represented with a half shaded in shape. It's not always going to be shaded in, but if it is shaded in, at least you know what it means. And thirdly, I crossed out this whole idea behind consanguineous marriage because in the olden days, like in the 1600s and the 1700s, family members were actually allowed to get married, but that's not the issue anymore, so we're not even going to touch that topic. So here's a sample pedigree. Notice the generations are numbered with Roman numerals, and in the generations, the oldest offspring are always going to start on the left. So as you look at this sample pedigree, make sure that you answer the questions below in order to make sure that you understand how to read the pedigree itself. These symbols right here, these are not part of the pedigree. It's mainly a key so that you know what the symbols are referring to. So how would I know if a trait that they're trying to track is dominant, recessive, or is it found on the autosomes, chromosome numbers 1 through number 44, or on the sex chromosomes, numbers 45 and 46? Here's some clues. If a trait is dominant and it's found on an autosome, you want to look for the trait happening in consecutive generations, meaning that every single generation is going to have that specific trait. In this example, the disease happens in 3 consecutive generations, and males and females are affected with roughly about the same probability. If a trait is recessive, again, males and females are both affected, and they have an equal probability of getting the trait. The trait is typically found in siblings, not in parents, and the parents of affected children may be related. If a trait is found on the sex chromosomes, the X chromosome specifically, the disease is never passed from father to son. Males are most likely to have the trait, and all of the affected males are related by their moms.